Okay, Ahlan Masahlan. Welcome to Data Science Onboarding on KSL platforms. So, if you don't know, you might already know, but if you know, I'm telling you, my name is Didier Barras Bautista. I am part of the KVL team, the KAUST Visualization Core Lab. As a matter of fact, have different expertise. You can see here all the members, and it has 2 data scientists. One of them is me. Now, why I'm giving this talk is because we actually, as you can see in this non-doctorate at all picture, the KSL is actually bigger. We form part of the KSL, and you can see all the people here is working behind the scenes in Shaheen and Ibex. This is all the faces. So if you find them in the wild, grab your Pokeball and try to catch them. So, for us, the idea in the KSL is that we have to provide you with state-of-the-art facilities, meaning supercomputers and some other connections that you might not know. Also the training to use them. And of course, because we want to do, supercomputing world-class here in Saudi Arabia. Okay. Now, how can you find those? Or where do you find the information? You have a list of all the things that we have for you. We have this link to the wiki that if you take my other workshops, you know about this website. In that website, I actually have something called the Ibex starting pack. And highlight there on the red square is something really important that you should always read, that it will give you access to Ibex completely. If you haven't done that, please do it right now. Check the website, okay? And then we have also a Slack channel that you can form part. But most importantly, we have the docs, the documentation. This is new. This is the best way to access all the information about how to use Shaheen and Ibex. Please use it. We have these emails addresses where you can write tickets or ask us. And if you want to find me, for example, you just have to Google sexiest man alive. And then you will find Henry Cavill after me. Okay. Anyway, jokes aside, let's start. What are KSL platforms? What we mean by KSL platforms are the supercomputer. This is Shaheen 3. This is the flagship. Okay. If you see and you are reading correctly, we have almost 1,000,000 cores. Okay, 800,000. So that's a lot computing power. And if you know a little bit, okay, raise your hand if you're a computer scientist. 1, 2, 3. Okay, so you know about AMD and all these things. For those of you that are not computer scientists, this is the brandest and newest and fastest that we can get here. So they're super well connected. It has a lot of power. And what you see there, this picture, that's the actual machine that we have here right now working. Okay. So Shaheen file system, or what we call file system, is where you should land and where you should work. So for Shaheen, you have, for example, a home that is actually shared between Shaheen and Ibex. So the files that you see at home, you will see it in both clusters. Then you have different parts like the scratch, where you should work and where you will work. As a matter of fact, you cannot work anywhere else. And you have something that is called projects. And here I highlight things that you can do on those parts, right? We have now a partition called bandwidth, and we have another partition called IOPS inside of your own scratch partition. And you can see, for example, the quota. These 80 terabytes are per PI. So your boss is entitled to 80 terabytes distributed among you and all your peers or colleagues, okay? Now, going forward, we have another cluster. That's a KAUST cluster for you to use. I'm sorry for the guys in YouTube that are not part of KAUST, but this is part of our tools, basically our facilities. So Ibex is more like a cluster made of parts. Think about as a Frankenstein, or what we all people call it a Beowulf cluster, which is made of parts of different CPUs and GPUs. As it is intended to show in this slide, it has different parts of CPUs. As you can see here, we have something called large memory nodes, which give you a lot of RAM to accommodate huge data sets, but this is only CPU. Okay. Then we have some other, we have some Intel Skylake and Cascade Lake with a lot of cores, 50 cores, 50 CPUs to your disposal. That's a lot of CPUs. If you can use them all at the same time, you can do work like this, right? And we have AMD for those that you don't like the mainstream Intel thingies, then you can use the ROM architecture. And those also have a lot of cores, as a matter of fact. So depending on your kind of work is the one type that you should choose. I mean, if you have actual needs for that. Now, the UC part of the Ibex cluster is the part that we have with GPUs. So these are all the GPUs. When I arrived here, there were only P6000 and then P100s. And those were the first GPUs that arrived here. They are super old. I don't think any of you actually have heard about them because you look young. And then you have the GTX, the RTX, that in that moment they started to realize in the world like, hey, we can use actual GPUs to make, calculations of matrix and then tensors. And then it's like, we can do deep learning. And then the B100s arrive here. So the B100s are our workhorse in the most part of the deep learning workloads. And then we have a very few, but very, very busy A100s, which are the top brands, let's say. Right now is the latest generation of GPUs that we can get our hands on. And okay. So the next thing is the Ibex file system. So as you can see, it's different from Shaheen. You have home. It's the same home between two of them. Then you have something that is called Ibex user. That's where you have to work. Why I'm telling you this? Because we have so many new people coming, so many people saying like, hey, I cannot write a file anymore. It's like, yes, you're working at home. You're not supposed to work there. Why? Because you only have 200 gigabytes. And then it's like you're just working blindly and filling 200 gigabytes of data very quickly. So this is why you have to use Ibex/user. So in Ibex/user, you have 1 terabyte for you. That is apart from something that is called projects that I don't put here. That is something that you can ask with your PI. It's like, hey, we need, not 3 terabytes, but we need like 5 terabytes for this project. You can raise a ticket. You can write in one of those emails that I show you. It's like, we need this much terabytes for this amount of time. Please give it to us. Usually the PI goes CC and it's like, yes, please do that. And you grant more, they grant more space. The system administrator grants it. It's not me, by the way. I'm not guilty of that. But you can write to the Ibex team and they will allocate some space for you. This is a common practice. Okay, now I want you to see those red things that I put there. Why no data sets there? Because it's very small. And home is not actually well connected to the supercomputer. As a matter of fact, I will show you right now a very quick overview of the resources. So, okay, Shaheen and Ibex are different machines and they have different requirements. Because you are here at KAUST, for you it's very easy and very direct going for Ibex. You just have to check that website that I told you at the beginning, because you have to be associated with a PI in order to fully use it. Just by default, you can use Ibex, but not the full power of Ibex. Then if you want to use Shaheen, then you have to apply to actually get access to Shaheen with a project justifying, hey, we're going to use these many core hours and we need a bigger computer, and you have those clusters there with CPUs. It will go over an application process. Now, there are 2 ways of submitting a project proposal. One is a development project, and then it's a production project. I advise to you to go for the development project. It will grant you with 2 million hours, core hours. It will be faster to approve, and is really easy for you to start working on Shaheen. Okay? The development project, the production project is different because it's like, then you have a working software that you just want to use 10 times or 1,000,000 times. That's why it's a production project. The development project is more for you to go around, check if your software works or not. Okay? So start with that one. That's my advice to you. You don't have to follow it, obviously. But okay, so I was telling you this about what it looks like a generic HPC cluster. You will connect through a terminal, and then you will land in a login node. That login node, to start with, is way less powerful than the computer you have in front of you right now. Your laptops right now, way bigger computer power than the login node. Many new arrivals and many people goes and try to do computing things in the computing node. It's useless because it's not connected to the real supercomputer. The real supercomputer is this parallel file system that you see here and the computing nodes. These two things are actually connected by special cables that allows them to communicate very easily, and that's the supercomputer, not the login node. Why I'm making this so freaking tired about the login node? What you see here is one user that came and he started to use the full login node for everybody. What he did was to run something called Mathematica. So he was, probably a new student, and I blame the PI for that he thought, I can run this just like I run in my machine. An HPC cluster is not your personal computer. So he started running this thing. All those red bars that you see affected everybody on campus. Nobody could log into Ibex. All right? If I were the actual manager of Ibex, I would ban this guy at least 3 months and tell the PI, you did a bad work. But I'm not that guy, and as a matter of fact, the managers are such nice persons that they didn't do that. So in this thing, when you actually log in, you will notice alongside in your terminal that there is an add login something. That's the login node. Do not do computing anything there. All right? Again, because one is a slow thing, two, you have only 2 gigabytes, and of course, you're not accessing the real supercomputer. Okay, so first exercise. Please log into Ibex. So for Ibex, we have 3 login nodes. We have the G login node, the I login node, and the VS Code login node. That VS Code login node is because VS Code is a very popular GUI now, and people use it. So to use that one, you have to know VS Code already. So for those of you that are using Windows, please use either PuTTY or MOBA Extern. We advise to use MOBA Extern because you just download it and copy here. And then for you that you're using Linux or Mac, please log into the G login node, okay? Right now, because then we're going to keep going. After you log in, please go and write the following, these different commands that are here on this part. Okay, everybody has something to log in, right? Good. So when you're done, raise your hand. You're done. Okay. Can you tell me what happens when you do who am I? It's your username, right? Okay. Now, the other thing that I want you to do is actually to do module AV. That one is interesting. For those of you that are already in the terminal, and inside Ibex, type module AB. Okay, did you reach that part? Okay, tell me, what do you see? All the modules and applications that are available on Ibex, exactly. This is how you actually query Ibex to say like, hey, what's going on here? Like, what do I have available to my disposal? Okay, raise your hand if you already typed module AB. Okay, you're still logging in. Okay, so another one that I like, please do cat/etc/Red Hat release. Okay, so it should say Rocky Linux 9, correct? Or am I wrong? So that's the operation, that's the OS, the operating system of Ibex right now. Before we had CentOS, which is a discontinued operating system. Now it's Rocky Linux. Okay? Now, the one that you probably want to do also, df minus tkh/ibex/user your username. That one here will tell you, one, if you have that available for you, and how much have you actually have used. Where are you? Okay, so it's just asking you to say yes or no. Weird. Okay, close that terminal, open a new one, and check it out again with the G login. Okay, yes. Sorry, again? So you type, what you type is df minus tkh, or which one do you type? Quota user? Quota user, it should be your quota in at home. It should have like 2 gigabytes. That one is the quota that you have at home. But it says no limited resources used. So you have an empty home, pretty much? Or you have a lot of files there? Okay. So let me change to my terminal. I will join you in a second. So in this case, what we did was like this. Then my user at glogin.kaust.edu.sa. Yeah. Something is missing. Is glogin.ibex. There you go. Then my password. My correct password. Okay. So you should have seen something like that. Did you access? Finally, excellent. So by the way, when you access, there is a very nice thingy here. That is your daily message from the system administrators. Sometimes they put information here that is very important, like, hey, we're going to shut down Ibex for X amount of days. Check it out once in a while. Okay, so in this case, if you do module AV, you have all the list of different applications that you have all the way down here, right? You saw all of them. By the way, that font is okay? You see it fine? Nice. Okay, you. So what my friend did was quota. correct? That one? It was quota S minus S user. In this case, user. That's it. That's what it should appear. Here you have your limit, your quota, space used, files, and the limit. Also, you have something called grace. Do you see that? Or is it different for you? It's different. Okay. Probably you don't have yet assigned an API. But okay. So by the way, if you do echo user, that's basically your user. That's a keyword. Okay. So let's go back. Everybody got to this stage, correct? Fine. You didn't? Are you logging? Okay. Could you do module AB? Excellent. So this one didn't work? Who raise your hand if it didn't work? 3 of you didn't work for it. Okay. Meaning either you are old users or you still haven't have the full access to the users, to the Weka, to the partition of that one. Okay. In that case, you should have something called, it was Ibex scratch. I think it was this. So look for yourself on this, like Ibex scratch. You have Ibex scratch. You 3 that didn't have, you have Ibex scratch. Okay, you're going to work in that. You can actually raise a ticket and ask for the user partition because we are moving towards that. In my case, this is my partition. Okay, let's clear this. By the way, as you can see, I told you, you will see next to your name that you're in the login node. Okay? Nice. Fine. By the way, I want you to do now module available M or module AV M. Just like that. Tell me what you see. This one. Yes. Go back. Yeah, module available M. It should list all the applications that you have. The name starts with M. In my case, I'm interested in the machine learning module because that's the one that I maintain. That's the one that data scientists use, right? Okay, so far so good? Nice. Okay, next stage. We actually, for those of you that are interested in doing deep learning or some kind of database that you need, there are such thing as Ibex reference data folders. These ones are very specific for computer vision, but we also host databases for example, bioinformatics. If you know that you and your colleagues are going to use a data set that is very big, talk to us. It will be put in somewhere like /Ibex/reference, and you can access it. Everybody will be able to access it. So you don't have to host it yourself. And it will not affect your 1.5 terabytes of storage. All right? So in this case, just to recount, please do not put any data set in user home, even though is actually shared between Shaheen and Ibex. Use your personal space for development. It will be your Scratch in the case of Shaheen, user, or Scratch also in /Ibex/Scratch for those 3 of you. And then in projects is on demand. It will be assigned to you. Then the reference, you can use it. You can talk to us if you need a reference dataset loaded on Ibex. Okay? And there are some special partitions on Shaheen. Okay, but we will not talk about that right now. Anyway, so let's go to the job scheduler. So many people here comes They are new to this kind of things, and they find this monster called Slurm. So it's actually a friendly monster, but it's something that you have to learn. This is the way you talk to the supercomputer to actually ask for resources. Okay? It's a little bit complicated. Yes, there is a lot of documentation about it also, but we already did a lot of work for you, so you don't have to go all the way to learn completely Slurm. Okay? What I mean by that is that we have some nice things to do. For example, if you type ginfo, you should see something like this. Type it in your terminal right now. Okay? Does it deploy it like this? It should read something like that, right? Now, this is an in-house check for the GPU resources. It's actually something that people use a lot to say like, hey, I want a GPU. I see like the B100s are 55 of them are idle. Why I'm not getting a GPU? Or some of them are drained. If they are drained, we actually can just restart them and give them to you. All right? This is just to check how is the status of the whole system. The A100s are always basically used. But for example, if you need a GPU, any GPU, maybe you can use a P100 or an RTX. The next one is also very useful. Like for example, sinfo, system info. I want you to type right now on your terminal, especially the second one, sinfo -nel. You can write the three of them, okay? The second one is a special one that I want to discuss with you. And the third one, if you do the third one, you will get something like that you see here on the bottom. Okay, so just let me know when you do two of these. Raise your hand, and we move on. Yes, sinfo -nel, the pipe. I want you to pipe that result to grep, and then the result of grep, I want you to pipe the grep, and then to get only what starts with cn. Okay? sinfo also can give you a nice format. That's the first line. Okay? You can play with the format, how it gets the output back to you. Okay, if you do two of them, let me know. Any questions so far? I see you're typing, so you're busy. Don't mind my question. Each keyboard is different, but in my case, that one is Shift 6. You have a Mac? Shift 6. Did you come to my shell workshop? No, that's your mistake. All my workshops were connected. You see, this is the power of the terminal. Okay, you got all the way down to grep cn, right? So were you able to see? Now what I want you to see is basically a list that starts with cn, right? So the second line is actually for you to see how many CPUs there are with this mixed precision, mixed 180, but they are available probably. Okay, is what you have as a resource. Very easy to query what is available right now. So you can adjust what you're going to ask for it. And then if you do this as info, grep B100, you just grab everything that is a GPU B100, what is available in the system. This one, for example, each GPU have a combination with a CPU. You can see it in this second column. over here. Okay. So I want you to do now something crazy. I want you to type SQ. So if you type SQ, only SQ, what happens? It's an infinite list, right, of stuff. As a matter of fact, you will see something like that I show in here in this part. So SQ is the way you talk to Slurm to say like, okay, where is the jobs? But it lists all the jobs in Ibex from all the users. Not only yours, everyone. And you will see different kind of jobs, for example, CPU or GPUs. Now, if you don't want everybody's, you can use, for example, this -- me, and as a matter of fact, do SQ -- me, it will come something empty because we haven't started any job, but that's your jobs. And also you can use -u, your username. I could actually check somebody else's if I know the username of somebody else's, but what's the point? Okay? So also you can go for a particular job number. The job ID that you see here in this column, you can put it there and you can see if it started or not. Okay? We will check it out later with one of the exercises. So you can request, usually what you want to play around is you want a CPU, a GPU, what type of memory, how much memory, and then the wall time. That local disk space also can actually be play around, but the three main things that you want to change are wall time, CPU or GPU, and memory. Now, this has to be on a script. And those scripts, we have done it for you. The scripts are actually something that we call batch mode, which is literally calling the resources from the supercomputer, and they stay there. It doesn't matter if you turn off your computer, the job is already running on the supercomputer. You turn again your computer on, the job is still there. There is another type of job, which is interactive. That interactive job is going to live as long as your computer is on, or you hit the time, the limit time, okay? The two things are kind of different because one is meant to be very, very short to prototype something really, really quick. And the other one is like, okay, I want to do right now something for 6 hours or 7 hours, then I want to go home and continue, then you need a batch mode script. Okay, that batch mode is something like this. You first have something called oh my God, I didn't check that. Job script, not job script. And it starts like that. It looks like a shell script, but you have to attach those things that you see here called sbatch. You can put the name of the job. You will ask for this task is basically equals to how many CPUs do you want, or how many nodes, or I mean, you can play around. Then you are asking for one GPU of the node, and then for a time, this is 5 minutes. Then after that block, you have another block that is like, okay, I'm going to load all the applications that I need from Ibex, or I can load my own. It depends on how you're going to work. Like usually we have the applications already done for you. If that's enough for you, excellent. If you have to fine tune it, then you can use, for example, conda environments, another of my workshops. Okay. For those of you that have full capacity, this will be very easy to get. For those of you that are not, I don't know if the next part is going to completely work, but we will see. So one of the things that people ask a lot is like, hey, what's going on when I have PD or GC or CG in the queue mode? Those are codes from Slurm. PD is pending. It's just trying to get the resources to give to you. But remember, this is not your personal computer, so you're in a queue. You're in a waiting list. And something that I found that pretty much people doesn't take too much care about is like if you ask for a small resource for a short time, you're on the top of the list because this is not first come first serve. It's like how much do you need for how long. So when you are trying to get resources from Ibex, the trick to rapidly get something is, okay, I need the minimum amount of stuff for, let's say, a minimum time. How much time? It depends on you. But it could be a small resource for, I don't know, 6 hours. That's fine. It will take time. But if you're asking for 4 nodes of GPUs for 5-6 hours, it will not enter right now. It will go on the last part of the queue. The more resources you're asking, then your priority drops. So if you're asking for the whole Shaheen, you're going way to the bottom. If you're asking for 1 node of Shaheen and use 1 CPU in Shaheen, it's like, have it 24 hours, no problem. We have 800,000. Okay. So there are 2 different ways to actually ask for that interactive job that I told you. One is this one, slog. So why don't you try to run this command like this? Even take out the constraint. You don't need to write constraint. Just slog dash GPU equals 1 time, I don't know, 5 minutes, not 10. Just 5. Right in your terminal. You will see it. You will see something like slog, pending job allocation, blah, blah, right? And it should return to you the prompt in the terminal. Correct? Raise your hand if you wrote it. Okay. So it returned to your terminal, right? For those that return to your terminal, now do the sq-me. What did you see? Aha, you can see the job ID that is probably pending or running, something like that. Okay, did you reach that stage with slog? Is it running? Okay, now you have actually allocated, ask Ibex for an allocation of a GPU, but you're not inside of it. You're still in the login node, don't you? Okay. Now there is a way to enter there. We will come to that one. Okay, so sometimes you can do even this inside of the login node. You can load all the material, but right now in the login node, you will not see this. Because basically, this is for running inside of slog. Now, let's jump ahead and let's try to do this instead. Now, I want you to write srun -GPU equals 1, and then time, again, 5 minutes, -pty bash -l. Again, I want you to run srun -GPU 1. Then forget about the -e, forget about reservation, put -t equals 5 minutes. No, don't worry about the module CUDA right now. So srun -GPU equals 1, then -t, time 5 minutes, okay? -pty bash -l. Okay, did you get it? Yes. slog, if you right now if you have sq-me, is running, but you're not inside of the GPU of the CPU or GPU node. Run this, and you will be automatically inside. Okay. So let me show you. If I yes, you will whatever you are right now, wherever you are right now, you are in home, right? Now, if I do let's run like this. Let me modify a little bit this. Instead of 50 minutes, let's do 1 minute. I'm going to use a partition that is called debug. We're going to talk about that later. And yes, now it's going to allocate. Do you see this change? This says login node. This says GPU. Now I am inside of a GPU. Now I can load, module load CUDA, for example. It will load CUDA. I'm still here, but then I can go anywhere. You see? You're navigating through the Ibex using this GPU. If you do NVIDIA SMI, I can see there is nothing there. Right. Great. But that's odd. Should give me something. But anyway, so right now, you're not in the login node. You can compute anything. You're inside of the supercomputer. Once your time runs out, you will be out. But if you want to get out before, for some reason, right, exit, and then you're out, and you're back in the login node. Now, if you do SQ, that's just me, you still will see the ESA lock. So the ESA lock will run forever. Well, not forever. ESA lock. It failed. Okay. Fine. Anyway, let's start with something different. So now that you have you still have your ESA lock there, right? In the SQ. Now let's cancel that. How do you cancel a job? You can do cancel the job ID, cancel -J, or if you have several running, you go for cancel -U, your name of user. Okay? Those are the three things, but they are very different. Cancel the number, the ID job, is going to cancel that ID job. If you use user, it will cancel all your jobs. If you use if you have two jobs right now running, if you want, let's cancel them. Do cancel -U, your username, they got canceled automatically, all of them. Okay, have you canceled all your running jobs? Okay, thumbs up if you have canceled all your jobs. Yes. You, my friend, you still have problems. Okay, so you haven't run the ESA lock, for example. It doesn't work for you. We have to talk to your PI. But anyway. From your Ibex. That's all. So, sorry, what are you saying? Okay, so yeah, sometimes it takes time to cancel it. If you do SQ-me, this is an empty one. Okay, you should see job partition, time, blah, blah, blah. If you have something running with ESA lock, you just take the cancel that job ID. Well, in this case, let's say 1, 2, 3, 4, and it should cancel that job ID. Sometimes it just takes time because it's like, okay, now I'm trying to cancel it, it's still running something inside, blah, blah. Eventually, it gets canceled. Yeah, once you trigger cancel, it doesn't stop. It will cancel it. Okay. Next, exercise 2. Yes. So for this one, we're going to do, for those that you have /Ibex/user, go to that one. For those 3 that you don't have it, go to Scratch /Ibex/Scratch/user. Then inside of that, I want you to git clone that repository, the data science onboarding repository. Yes, questions? Sorry, mate. It's like, yeah, you don't even have access to your Ibex/user. You have a Scratch. Okay. You don't have it either. Okay. In your case, we can do an exception. You can do the git clone at home. It's not that heavy. So do the second line at your home. Okay. Let me know when you are done with git clone and the third part, which is changing directory to JavaScript templates. Yes, it's git clone HTTP, all that thing. You can actually look at that in the internet. That's a website. That's our data science. Basically, GitHub of templates for jobs. The correct access rights. Where are you in your CD? Really? Access rights? It's a public one. Huh. Let me check. If I go here, I'm going to cheat because I have this here. This is the GitHub of the KRCCL. I have data science onboarding here. I'm going to code, then copy this, and then git clone this. Okay. But it works for me. Sweet. Okay. Technically, this should happen for you too. But since I'm one of the maintainers, I do not know. Did it happen for you? It worked? Okay. Everybody has it? Okay, excellent. So, because I already have it in my Ibex user, what's my user? Yeah. And then data science. Okay, so inside here, you will see different files already. So I want you to go to templates. Not that one. JavaScript, sorry. Templates. Okay. In this one, come on. Like this. Okay, so in this one, you will find basic Slurm. So now I want you to submit it to Ibex. How do you do that? You write sbatch basic Slurm, and it should say something like this. Now, let's check what is basic Slurm. So basic Slurm here is an example that we have for a batch JavaScript. Okay, so you have first your name, your job name. We're asking for just one task. We're asking for 4 CPUs. We're asking for 1 GPU, whatever GPU, 1 GPU in the node, and 5 minutes. Now, we are actually loading modules from the GPU stack, and then we are loading the machine learning module. Okay, this is exactly what I told you before. So it should be there. And in theory, when you exit, probably for me, it's already done. Yes. So at the end, you already have something that is slurm and the number out. That file called slurm, the one that starts with 355 in the bottom of the, let's put it better on the, this file here is basically the output of that JavaScript. Very quickly, we can check it. So if it succeeds, you will see something like this. So the first thing you will notice is like it's telling you, hey, we loaded this module and then we load these other modules here. That's the first part. Like we loaded machine learning module 2024-01. Excellent. And then in the bottom part, you have like, okay, is there a GPU? Yes. What's the properties? Yes. How many there are? The total memory, the type of microarchitecture, which CPU, blah, blah, blah. So we are just querying the system very quickly. And you just run your first S-batch run. Okay, this is This is not an interactive. This is a batch run. And as you can see, the keyword here to submit any job is S-batch. And then your script. By the way, given that it's already 1 hour into it, do you want a break? Or should we keep going? Mixed reactions here. Okay, let's take a break of 10 minutes, all right? So you can breathe, get some coffee, get back in, right? Okay. Now we're going to keep doing exercise 3, but before okay, I will wait for the other 2 Mac users to come back, and I will show you a trick. But at the moment, okay, now submit a job asking for 2 GPUs on a node. The hint is now use that one, multi GPU single node Slurm. It should be also in the same folder. Okay, so now we're in exercise 3. Check for that multi GPU single node Slurm. Just do sbatch. You can inspect that file if you want also, but it should be just sbatch multi GPU single node Slurm. Okay. Now with SQ, in theory, if it's quick enough, it should be already done. And now you can check the output, as a matter of fact. You should have another output over there. Okay, does it happen for you? No. Okay, we have to check what is inside if it doesn't happen for you. So, for example, one of your colleagues already have a constraint over there. Let's go to multi-GPU, CPU nodes. It's this one, right? Okay, so here you have a constraint, right? It's asking actually for B100. In this case, we're actually asking for 4 GPUs. It's going to take time. So if I do sbatch multi-GPU, mine is submitted. If I do sq-me, now it's running. Okay, so does it look like this for you? It's the same. And when you do sq-me, does it appear for you in your queue? Mine's already done. So I have a new output here. And that output is just asking like, how many GPUs do we have? 4. Now, for those of you that didn't run, we can do something. We can take out the constraint and it should run. In your case, it looked like constraining is actually backfiring. Now, we can do nano multi-GPU single node. And then we can either silence this attaching one more hashtag, or how young people call it these days, I don't know. And then Control O to overwrite, Enter to upset the change, and Control X to exit. Now if I do cat multi-GPU single node, this constraint will be silenced. If I do the same sbatch multi-GPU, it's submitted. Were you able to submit? Well, okay, I will wait for you. In this case, sq-me, already done. So previously, we have 4 GPUs. The name is Tesla V100. Now, what did I get? So silencing the constraint, it gave me P100s. You see, Tesla P100 instead of Tesla V100. So silencing the constraint will actually automatically change the settings for Slurm. It will give you what is available. Okay, how many Mac users do we have? Raise your hand. Oh my God. Okay, I'm going to give you a trick this one time. It's not part of the workshop, but it's going to probably help you a lot. Okay, go to the Finder. That's Finder. You see this thing here, Go, right? In the Finder, you should go to Go. There is a thing that is called Connect Server. Click that. I don't know if it's a large enough font, but now I want you to do smv dot dash dash double dot sorry dash dash samba dot ibex dot kaust dot edu dot sa. For you that you have MovaXterm, technically you don't need this because MovaXterm already give you like a file manager there. I'm sorry, it's not large enough. And as a matter of fact, these are on our documentation. How to connect through Samba. Okay. Double dot, dash dash Samba, Ibex. Okay. If we push connect here, it will ask your credentials. Okay. Now, the first one that you should find is your user. If you push OK here, it will open your home directory in Ibex. Okay? Give it a minute to load. This is my home on Ibex. Now, I can drag and drop stuff over here. Like, for example, this. Drag and drop. And now this same file is on Ibex. Okay? Now that's your home. If you do the same thing, connect server through the same thing, you can save it down here, by the way. You connect, okay? And now on the list, for those of you that do have the /user, you go to Weka user. For those that you have Ibex Scratch, you go to Ibex Scratch. So because I have Weka user, I have the /Ibex/user. I will find here the list of everybody that has the same partition. Give it a minute to load because we're like 1,000 different users. So in here, I will have to find again my username. It will take time to load, apparently. Well, going back for home. If you have something here, you can actually double click it. And now you can edit that file in your computer, and this will be actually reflected on that file. Yes, a question. Because you want to go to another user's builds? Okay. If you're here in Weka user, you're at your home. You do not have access to anything else but your home. You cannot go one up. The system will not allow you, because if we allow the users to do that, they will create havoc and the computer will be useless. The supercomputer will be drowned with stuff that nobody wants to deal with. But if you're in Weka users, you see all the users here. Okay? We have 1,000 different users. I will go to my folder, which is way down here because we have a lot of L and B of boss. Here I am. You will find your own because it's not blocked. You see this mark, red mark? This is another users. I cannot enter another user. I should not be able to do that because people should play nice, but let's better keep each stuff separated for everyone. If I double click here, now we deployed everything that I will have there, obviously. You can see all the stuff that I've been working with. And now I can go for data science onboarding. And now I can go to templates. And you can see here. Doesn't like it. Okay, open it with text edit. And now I can see the same result here in my computer. Okay, this is the same I was showing you this. This is how you mount Ibex on your computer to work with your tools there. It's less painful. It also enables you to do drag and drop things for small files. What I mean is like not more than 10 megabytes files. If you want to upload bigger files to Ibex, you need special commands for that. This will only work for small-ish files, okay? So in fact, now, let's put this here. If you were using with me this single node here, we can open it with text. And you can see here. Now I'm going to save this. And if I go back to this part here, where is it? Multi. Now the change is reflected here, you see? So now what I show you for those Mac users, you can work on your Mac and the change will be reflected in the supercomputer. Okay? Everybody happy with that? Nice. I hope you are, because if not, I cannot make you more happy than that. Okay, exercise 4. Now submit the multi-GPU, multi-node. Okay, same exercises that we have been doing. Now do that, the multi-GPU, multi-node. Because now we started asking like 1 GPU in one node. Now we ask for 2 GPUs in 2 different nodes, that they don't have to be close enough. And then we're going to ask for 4 GPUs in 4 different nodes, if I recall correctly. Okay? Hands up when you are done with that. Yeah, you submit it? All right. Submission done. As a matter of fact, it doesn't take it. So multi-GPU, multi-node. So we have, for you, the constraint has always been a problem, right? Okay, silence that one. Everybody else has problems with the constraint? Not now? As a matter of fact, let's change the name to, instead of my first job, my multi-node. SBatch, multi-node, SQ, that's just me, is there, is running. I'm asking for 4 nodes, 1 GPU in each node. It will take no time. ls-ltr, tail to see, I guess still running. Is done. Okay, so in this case, this should be the output. And there you have it. We have 4 GPUs, and each of these repetitions here is for one node. In this case, I got the B100s. Yes, the B100. I hope for you that you remove that is going to give you something like this or an RxDX. Okay. So when you hit SQ, that's just me. Here in node list says required for something, right? So your job is still pending. It's still not, it hasn't gone through an allocation. It's waiting for the resources. We have many people asking us about that. Here in node list, sometimes it appears something like, hey, these nodes are requested for something. What it really means is like, is looking for the release of those resources. It will take time. So you're in the queue, leave it there, go home, take your coffee, come back, relax. And then it will eventually go through. But don't worry about it. Or so far so good. Okay, everybody got through this. You reached the submission limit? You do not have your PI. So that's the fault of your PI. So bad PI. Yes, if you, like I said, in my web page, in the one of the visualization in the data science tools, you will find there the link that you have to fill out. That will trigger a email for your PI, and your PI has to hit accept or something like that. And then you will have full access to Ibex. You do not have full access to Ibex right now. Okay, so exercise 4B. Now, I want you to do this. There are 2 parts. The first is run slog like this. Oh, go back. Yes, run slog 1, 2, 3. This is one part. This will trigger slog and allows you to get into slog. Okay, and then you can do this run. As a matter of fact, I will do it with you. slog, time, 10 minutes, nodes 1, partition batch. slog. Zero, zero. Yeah, 10 minutes is fine. And then node 1. Yeah, that's just partition. Oh, how do I spell it? Batch. My English is not very good looking, sorry. Okay, that should trigger this. Fine. So I have this allocation here, this job ID, right? It's going to run forever. Then srun, that's just job ID, overlap PTY. This job ID here. PTY bash minus L. It's like that. Just bash. That's just overlap. Is it like that? srun dash dash job ID dash dash overlap dash dash PTY. Okay, it should look like this. Let me put that even bigger. Okay, srun job ID. Now, see the change? Let's clear this. See, now I'm here in the compute node. If I do SQ, that's just me. I see it's running. It's interactive. If I go exit, I'm back in the login node. But my job is still there. It hasn't disappeared. is still running. For the next 10 minutes, I will have that to enter every time I want. Go back with this. I do srun, and I'm back into it. It doesn't stop. All right, so here I can module load stuff. Anything. Well, I cannot load machine learning module because it's not in the compute nodes of CPUs. But did you get to this point? Is it running for you? Did you did the overlap? You get a warning with overlap. What's with your username? Bin. Okay. So probably you have to do something like minus L, bash minus L. Sometimes it's like bin / bash minus L. Maybe it works. It's a small change. And it should still give you the warning like, I don't like that bash. Okay. Okay. Now, the second command that I want you to run is this one, srun time. Actually, matter of fact, you already run it, right? Once. So instead of rehashing the whole thing, why don't you hit Ctrl R and you write srun? Probably it's not going to give you that one. But we can do history, grep, srun, and it should be this one. For me, it's this one. Exclamation mark, this number. Memory required not available. Okay, I understand. Then don't give me the partition debug. Instead of debugging, just give me something. Okay. Now I'm in something. Okay, if I hit right now sq-me, I have this running for me, and I'm inside of a compute node. Hi, Theo. Okay, exit this. That should be it. Now, cancel the thing. salloc allocation revoked. It's done. There you go. Okay. Now, srun doesn't allow you to do other things while you have salloc. It will just trigger like, I'm going inside of what you're already running for some reason. Let's not fight with it for now. But if you do again the srun thingy, this one, clear. So now I'm inside of this sq-me, and I have again an interactive job here. The difference is like when I exit this one and then do sq, it died. salloc makes it survive this exit because it's just allocating and telling Slurm like, don't kill it. Keep it on the background. I will come inside and outside many times. That's the difference, and that's depending on your situation, what you want to use. Sorry? Yeah, salloc will tell Slurm like, give me these resources. Until I tell you cancel, don't kill it. When srun, it's like, give me the resources right now. When I exit, kill it. That's the difference. Okay. Yes. If you close the terminal with srun and terminating the session, the job stops and it kills. With salloc, it doesn't happen. Okay. Everybody up to this point? Nice. So I just want to remember the different login nodes. For Shaheen, there is a different login node. Then we went over slog and srun. Fine. So far, so good. Now we're going to do something different. We're going to use an interface between Shaheen or Ibex and your computer to use Jupyter. So this is another exercise. You already have cloned this. Now I want you to go to launch Jupyter server folder and launch this Jupyter server batch. There is a version for Shaheen, there is a version for Ibex. The version for Ibex is this one. Okay? If you have any problem, you can do this. But at the end, I just want you to launch this Jupyter server batch. Yeah, there is a Jupyter server folder inside of the Git repository that you already cloned. But you have to get out of that folder that you are right now. You have to get out of templates. It's like 2 folders up. Yeah, exactly. So, for example, we are here in this. So if you do cd dot dot dash dot dot, you're now here in data science onboarding. And now you go cd launch underscore Jupyter server. Now in here you will see this for Shaheen, launch Jupyter server for Shaheen, or launch Jupyter server. This is for Ibex. Now you can do this batch here. Okay, SQ. For me, it's running right now. Now this will create 2 files, one output file and one error file. You have to go to first this part here, launch Jupyter server, sbatch launch Jupyter server .sbatch. You will submit your job. Okay. Is it running for you? It's asking for 1 GPU, as a matter of fact. So if you check the last, you should have something called demo, the job ID, and then an out and an error. Then if we inspect this error file, there is a bunch of mumbo jumbo here, but you have to check the first part. So at the top of this, you can see is loading stuff, already modules, applications that are in the Jupyter, in the Ibex cluster. Then something here is actually in English. To connect to this node, you have to first copy this and paste it in a new terminal. This thing will create a bridge between Ibex and your computer. Okay, so we open a new terminal. We paste this. Again, it asks for the password. Okay, that's as far as you can go. Fine. Okay, now go back. This all the way down here, you have to copy this second line. Copy paste this into a new web browser or your web browser of preference. Okay, Give it a minute to start. And now you have a working Jupyter Notebook inside of Ibex. As a matter of fact, you can see it here. So for you to believe me, cat, it was etc, ECT, etc, Red Hat release. It's Rocky Linux. Who am I? This is my user. And as a matter of fact, I'm inside of a GPU. Okay? So I actually ask for, give me a GTX, a Titan. With this thing, actually, this has widgets like this, GPU dashboard. This is inside of the machine learning resource, that the module, sorry. And I can put it over here, so I can work directly over my Jupyter notebooks over here. And it creates the untitled here. I can actually inspect here the scripts. All right. So this is a way now you can work directly on Ibex to do your jobs, to your scripts, to do any kind of prototyping that you need. For example, import this, the send of Python. This is running right now on Ibex. Okay? Now, were you able to get to this point? I know it's very complicated because it's a two-step thingy. So if I actually go back to my terminal, let's make it a bit more. SQ, that's just me. This is running. Once I close this, shut down, stop, leave, the job is gone. Okay, now, again, I'm very slow. You have to do two steps. The first, as a matter of fact, we can do something even different. sbatch, launch Jupyter, and then launch Jupyter server .sbatch. That's step one. You launch your script. It doesn't matter where you are. I am right now outside of this folder. I can call it like this. Or I can go inside of that folder. Launch. Okay? The part here that you want to do is launch the correct script. That's number one. You launch this, wait for it to start. This will create two files. These two files are actually named, as you can see here. It's going to be the name that you put here, in this case demo, the job ID that is going to execute, and then slurm.out. And you have another that is error, the same. The name, the job ID, slurm.error. Inside this one is the information you need to connect to Ibex. So in this case, if I see this again, at the very beginning, it's going to tell me, I'm loading all of these things here. You're working now on this GPU here in this free port that is going to listen between your computer and Ibex. You need to copy this line, okay? But for that one to work, you need to open a second terminal, or you establish a second terminal. In this case, is this for me? This is another terminal here. Terminal on Ibex, terminal on my computer. Then I copy paste this and I give you my credentials. That's all. Okay. Let me see if it's not dead. Oh, it's running. This one. Cat. Okay. So this one here, I copy, paste the new terminal. Again, drags me to give me my credentials. Okay. And now I can go all the way down, copy the HTTP link, and I can paste it in a new tab on my computer. This second SSH command here, that's the link between your computer and Ibex. It's called bridge. Oh, no, sorry, it's called tunneling. So that tunneling, what it's going to allow is basically to just give you like a website-like link to access Ibex, but now with this UI. Yes, as a matter of fact, these are actually generated. Let me show you. Launch Jupyter server. So for those that are you savvy of this, what we're actually giving is actually exporting the runtime. This is to connect basically your output to the screen. We're asking your user, because some of you have credentials, some of you don't. Then we're actually asking what are the ports that are free, and then we put them here all together. Because the port always is changing, this value always change. Yeah, you run this command here in a new terminal, so it gets the dynamic movement or connection to your computer. And this is basically asking like, hey, establish a link between this port, this node, to this other port from the user in the login node, the G login node. Yes, you have to state the port and the node for it to work. In this case, because you are actually accessing directly the compute node. If you have a public key, Ibex won't have. As a matter of fact, I think it will, because part of the security things is like, this session is for you. In theory, nobody should access it but you, theoretically. That's why it prompts you to put your password again. So that's part of the security. And indeed, we could actually make it more secure, but this is already very, very difficult for people because 2 steps. I know that is bothersome. So raise your hand if you could deploy your Jupyter notebook. You deploy, okay. I don't know if you two have access. You probably don't. You neither. Okay, so one of the things. No, this is just asking for any GPU. Okay, maybe because we're taking many GPUs. Okay, so let's kill this. You can actually SQ is running. Cancel -u. My user. Okay, that's cancel. That should free some resource for you. Hopefully. Okay. So now that you have deployed that, you can now say that you can work inside Ibex interactively. And you can change that job script. You can take it home, change it with the name and time you need. Okay, so like I was explaining, this is the job script in general. Like you can change the name. There is a partition called debug, which is a very good partition when you have a very clear idea of the prototype and you don't need too much resource for too many time. The debug partition is basically 1 hour. And then it's like you run a code that you want to check if it's actually working or just to check new errors and try to fix them. Okay. And yeah, like I was actually saying, there are two lines that are important. One is the port. We're actually looking for ports where Ibex is free and listening to you. And this other line, that is the one that connects and makes the bridge between your computer and Ibex. As a matter of fact, this line here, the mail type all, if you successfully run, you will find in your inbox a mail that says your job started. Your job is not successful. If you include this one, you will know in your email when it starts, when it ends, or if something happened. Okay? Fine. Okay. Okay. Okay, let's work now with the... Let's go one more time. In this case, I want you to launch the Jupyter server in the following way. Go one folder up, do the sbatch, launch Jupyter server, launch Jupyter server again, sbatch. Okay, connect to that. Put exit here. So now mine is running. Maybe just head minus N50 of the error file. It was too much. It was too few. 20. There you go. New terminal. Okay. Now tail for this. And I will copy paste the whole thing. Okay. Now, if it starts for you, you will have your files here. You should know that now you can go inside of this is your repository. This is the data science repository that you clone. Now, I want you to go inside of notebooks and run this. Okay. Go ahead, try to run all this notebook. Meanwhile, I can show you, like we have stuff inside that uses actually the GPU. There are some things that are called CUDA data frames that are specifically for GPUs. We have installed that in the machine learning module. So I can run all of this. You can also run this if you want. This is shorter. It just is going to actually copy from this location a data. So if we do this, it's going to take time to load it. Well, what I'm doing here is actually executing a bunch of different pandas modules that are going to allow me to read 4 million rows in the memory of the GPU. It will also assess how much time it's going to take. Now, for example, loading this into the normal memory takes this amount of time. This is slightly smaller time, but then you don't feel it. And the thing is, like, now this smaller time is inside of the GPU memory. And I am working on a GTX. So at the moment, what I want you to do is basically go try to run this stuff. Check it out. Let's say, like, give it a try the next 10 minutes. And I will check with you too what's going on, especially you, because your terminal is strange. You don't have the resources yet, right? We can talk to your PI later. Okay, everybody were able to find and deploy the notebooks? You didn't find the notebook. Okay, so just for you to check, you go one outside. You're here. Okay. So if you do sbatch launch Jupyter server, that's step one. You're with me? Then that, if it's running, you do ls -ltr tail. You have something like this. You are in the Jupyter. But if you're in the Jupyter, then open a terminal and do print working directory. So here in the plus sign, open a terminal and do print working directory. Where you are you here? So you're inside launch Jupyter server. Okay, that's exactly why you're not finding it. You launch it from inside of the folder. So what you can do is copy one launch from launch, one folder up. Okay, like this. Copy, launch, Jupyter server, Jupyter server. Copy it in this working directory, and then launch it from there, from this directory. Okay. In your case, probably you. We don't have a machine learning module on the CPU nodes. Okay, for you, what I want you to do is to silence these two. For you, also, try to silence these two lines. Okay, just put here instead of that, something like this. Make it look like that. Okay. You could not even launch the Jupyter. You silence these two? Okay, but you did the 2 steps. I know, it's complicated. It's 2 steps. The first one is inside of Ibex. Here. So this is Ibex. You launch it from here with this command. Then in a new terminal in your computer, I started in my computer as a matter of fact, you have to put the other SSH that you will find in the error. You did that? Okay, that's the bridge that you need to make between you and your computer. The previous step says sbatch. Okay, that's odd. So let me take a look at your computer. Okay, can you allow me your computer a second? Okay. There you go. Finally. Okay. Let's clear this. Okay. Nice. So you're here in the login node. You are here on your home. Okay. Now let's exit from here. This one. Yes. Exit. Fine. There you go. Finally, you're out. Okay. Now for this one, if we have S batch, not torch, launch, Jupyter server, launch, server, batch. Okay. Now here, let's do u-me. Okay, you have this thing of the down, drain, or reserve for higher partitions. Okay, cancel. Minus u user. And we're going to then change it to launch server, because you're asking for GPUs. We're going to silence this until okay. Just want to see that. Is it silence? Yes. Okay. Batch. Launch. Ah. Let's see if the trick pays out. Because now we are asking, yes, compute nodes. So the thing is, like, you and your colleague, because you don't have the complete full access, you can ask for CPUs, but GPUs are tricky because you have only one, and we're getting like access that one like randomly, leaving you without the resource. But with this trick, check my website. Check the website I told you, because there is a link. It will trigger the email to your advisor. Hi. Oh, okay. I didn't break it. I'm sorry. Who knows? Maybe it is. So the thing is, like, now you copy paste this. Okay. You put your password here. Okay. So far, how are you going with the linear regression problem? So? You didn't get it also? Okay. So now, this here, you copy this one into a web browser. All right? Okay, are you playing with the GPUs? Okay, let's see. Where are you? You're at home. What is your data science onboarding? Okay. So if you go here into CD data science, okay. So you launch it already inside of the folder. So what you can do is sbatch, launch Jupyter server like this, launch Jupyter server dot batch. Okay. Now this is going to run. Okay, you have many right now, as a matter of fact, running. So in here, we can get these. So if you done this, what's the problem?
If you go here, here,
Okay.
I cannot find.
No, then you didn't do what I'm doing right now. What you did is launch it from what I told you. You launch it from inside Jupyter server. So we can kill this. What we are doing here on the other, so this one, where is move extern? Here. What we are doing is launch it from outside. Okay. Once we have launched that from outside, we can copy paste this. How do you copy paste this? There. Okay. So now you copy this one. So you already know. We copy this one into a new one, and then copy paste this one on the web browser. Yeah, do the same. Yeah. Yeah, come. So you're not going to be able to, because you have CPUs, you cannot run the GPUs thingy. But you can check now the linear regression or the notebook. Let me know. Uh-huh. Uh-huh. And it's running.
Yeah, shall I run
Yeah.
first? Then
Yeah, that command is inside of the error file. Both of them.
okay.
But
I should run this one.
you should
Okay.
go back. Go back. So check the last files that have been created. Yes. As a matter of fact, you have an error file here, right?
Here?
You see demo EID?
Yeah. I should run it.
Just check it out. Open it with cat, for example. Error. Error. Now on the top, you will find the SSH. This is what you have to take into the new. Okay. Open a new terminal. Okay. Now on the bottom of this file, the error file, copy this link, the HTTP. Yeah, the IP. Oh,
Login.
it's fine. That's odd. Okay, try this one. Yeah. Okay, it's running. Now you're in Ibex. Yeah, that's the reason we have to. Sometimes this doesn't work, the other works.
Oh, okay. Okay, but now
Yes.
I run
If, yes.
allocate.
Yes.
And now I open, and then I open
The file.
with, and I will get all that.
Yes.
Then I will get. This will create a channel. And then I will copy paste.
Yes, one of those links. One of those links should actually work. Yeah, one of your colleagues actually good at make a good point. So sometimes so far I have copied this link for your colleague, it didn't work. So you can copy this other link, and that probably will work. It's either or. Okay, so far so good. Okay, now I'm going to put you through more pain. Why? Because now we're going to launch another thing called code server. Yes. To upload? Okay, in this case, if I recall correctly, depending on what you have here, I think you can upload it here. But if you want, we're talking about gigabytes or terabytes of information? Less than gigabytes. Okay, I will show you in the documentation. As a matter of fact, if you go to the documentation, you just type rsync data transfer utilities. You have all the commands that you need here to transfer things from your computer to Ibex. If you have a Mac, I already show you how to drop, like literally pick and drop things inside of Ibex. But this is for, gigabytes of data. Up to 10 gigabytes in this case for SCP, super copy. Or you have rsync, which is my favorite, to upload a lot of things, heavier things. Okay. Now let me clear this. Where is it? Clear. Now. So going back, code server. Code server is actually the open source version of something called VS Code, which is very famous. It's a killer application from Microsoft and is very good. As a matter of fact, really, really good. Now, the same applies for the code server. It's 2 steps. As a matter, you launch the script, then you go inside of the error file or the out file. You do the link between your computer and Ibex, and you deploy as a web page. Same deal. So, as a matter, so yeah, let's do that. Now there is a separate folder called Launch Code Server. If you go here, you will find it here, Launch Code Server. So sbatch Launch Code Server, Launch Code Server Ibex. So now I have that job submitted. I have, here is the Jupyter Notebook. This is the code server. And here is the output of that. In this case, the code server has everything you need, but in the output, no, it's still in the error file. I was wrong. So what I like about code server 1 is that it's shorter. It doesn't have that many things. So you have to copy this again into a new terminal file. Again, your credentials. And what I like it is that you just have to copy this into your website, into your web browser, sorry. So it's 2 steps, but they are shorter, just less text between them. You copy this, you put your password here into the new terminal, and then you just deploy. It will tell you if you trust yourself, probably you shouldn't. But then you have, this is the layout of VS Code. But this is open source. Now it has, again, your way of navigating stuff. Now you have the 4 million rows here. You have also other ways to see your files. You can even open a terminal. Where is it? View terminal, here. And so you know, just know NVIDIA SMI. I have my GPU here. It's working on a 100. I got lucky. And on top of that, cat/etc OS release, no, Red Hat release. So I'm signed off Ibex, okay? But this is a different way of using, this is a different data science popular GUI. So you can develop code in this one and you can actually get your extensions. So extensions are what actually makes VS Code very powerful because these are modules that you can load into your VS Code and it can make your productivity skyrocket. You can actually try to GitHub Copilot. I think it's not in the list, but you can install GitHub Copilot here and you can basically use ChatGPT to help you with your code. It's not in the official list, which is very strange, but you can implement different type of different models that people has developed, like for example, prettier code. There are others, color CSV, some better CSV syntax and so on and so forth to check stuff that people has done. Yes. You have a welcome page. Okay. So code server is a little bit. Now, this is a big difference between code server and Jupyter Notebook. It's like code server, wherever you launch it in Ibex, it will let you open any folder. So, for example, if I go back to my home, like home, I can open my home. And I have everything in my home here. So probably that's why you landed in a different place. And then if you do open folder and you do Ibex here, user, and then your user, it just loads wherever you are. In your case, it's a Scratch, Ibex/Scratch, your user. For your user, permission denied? That's odd. Okay. So if you were able to deploy the Jupyter Notebook, you are able to deploy this one, for sure. Okay. Later, we can check about your permissions, which is odd. For you and you, the trick is that you have to ask only for CPUs until your PI checks the mark for you to use the GPUs. Okay? So far, so good. And then if I go here and I check this. So what I want you to understand is like these jobs will run. No matter if I just close this, I can just start them again I can go back home. I can be away from KAUST and I can connect to Ibex because these are running in the supercomputer. This doesn't depend on my computer being just working. I can actually try to connect with another computer. Okay? So now I'm going to cancel everything. My user. And everything is gone. VS Code. Okay, so for VS Code is sbatch, launch. Wait. Code server, launch code server, Ibex _ Ibex. Okay. So this will start running. The last error file that you are creating here, this one has all the information that you need. Okay, that's a very good question and a usually fatal error. People think that they can run your local VS Code. In Ibex, you can't. You can access Ibex with your VS Code, your local VS Code, but you have access to the login node, not the compute node. So people try to develop stuff with VS Code in the login node, which is completely bollocks. Yeah, because at the end, you don't have the computing power in the login node. So if I go here, you could probably connect with your VS Code using this. Exit. Let's go for exit. Glogin doesn't, the login doesn't have any power. It's worse than your computer right now. That's the mistake that people make. As a matter of fact, we have disabled the GPUs in the glogin node. You cannot use people. There has been quite different people that come and like, I cannot see the GPU from the glogin node because you don't have access to them because it has no power. You do not have power here. Okay? But if you do this and you actually create, you actually ask for the resources, you can try with the remote connection from VS Code, get it connected to Ibex. So this is the second step. Once you copy this, yes. Command not find. Okay. So let's go back one step. Did you do this? Like that? Yes, I trust the author because it's me. Okay, terminal. Fine. Okay, so when the command is there. So let's put this on. So you see how this is a GPU? Now you can use this GPU because this is a computing power. This is a computing part of the of Ibex. If you do NVIDIA SMI in the login node, it will not deploy something like this. If I recall correctly, it won't work. You will not find NVIDIA SMI. Now I get a GeForce. The other one was an A100. I got lucky once. Yeah, I mean, I can work, for example, with my local VS Code, do a connection, and use srun for an interactive session. That's easy. I do it all the time using the terminal in VS Code. I will show you after the workshop, okay? Okay, so everybody got pretty much the idea of how painful it is? Yes. Okay. So now I'm going to talk about something that is actually the next iteration of technology that you might use. That's containers. What is a container? To start, since you are not all like computer scientists or computer related people, a bare metal thingy is basically your computer right now. Bare metal means everything that I can install in my computer where I have the admin rights and I have no problem breaking it or disabling whatever. That's what bare metal means. When you hear anybody saying bare metal, that's what they mean. Now, at some point, people realize that we have different machines, and what works for my machine might not work in your machine and the other machine, blah, blah. And then people start using something called virtual machines. So you could run Microsoft Windows inside of an Apple machine and stuff like that. That is very heavy because it basically brings the whole operating system of one family with all the libraries and everything and trying to install it in your computer. And the more virtualization, virtual machines you have, the more it consumes from your memory and your resources, and is a mess at the end of the day. So the next best thing that people actually talk about is the containers. So what's the container? The container, think about it as a virtual environment that just talks to your machine and says like, hey, you have computing power there, give me some. So it's not installing anything, it's just running on top of what you already have and basically taking advantage of your OS, okay? And pretty much taking advantage of the computing resource you have. Why I'm telling you this? Because again, Ibex is not your personal computer. You do not have sudo permission to install anything. So if you want to install anything, you have two ways: the conda environment or a container. And depending how old is your the software you want to use, is one or the other. So conda environments are very easy to create, very straightforward. Sometimes they don't work. Containers, on the other hand, can basically go back in time and take everything that you need into an actual computer. So for example, one of the things is CUDA. Now, we have several companies that provide containers. According to their philosophy, they vary. The most known one is Docker. You see here Wally with the Docker image. Docker is everywhere, is super convenient to use. We cannot use it in supercomputing. So the replace for that is called Podman, that we just enabled this year in Ibex, just to run pretty much the same commands as Docker. But it's not super powerful either. What we have that is more powerful is Singularity containers. Now, that's a problem because you have to learn how to write it, but it's basically the same idea. You have a virtual environment that you can sit inside of the supercomputer and run it with all the computing power. Singularity was the first one to actually do that for security reasons. Docker hasn't, for some security reasons that I do not understand, Docker cannot be run in a HPC facility, but Podman can be done. Okay, so we have Podman instead of Docker. And I have videos to prove it. So this is an example of a Docker file. What you can do, and many people do, is to install Docker in your computer, run these kind of commands, create the virtual environment, upload it into the cloud, and then download it somewhere else, usually another kind of server. We can download this with Singularity or Podman in Ibex. So you can actually, I advise you to go and check out how to write these kind of Docker files. It's not that difficult and can be actually very handy. So this is what I'm telling you. Like what people do, and some other recommend, is basically in your computer, you go over these stages of building the image, changing the image, or annotating the image, then push it to something that is called a registry, basically a website, a cloud, and then you pull it from that service, that cloud, or that website into your computer. And what actually makes this technology powerful is that you can use different containers in different steps of your workflow. So you just need to pull it and run. You don't need to create anything else. You just put layer or layer or layer, and it's like, okay, I want this container now, this container now, this container now, blah, 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 blah. And then you have a whole stack of a workflow. This is how, for example, other companies, big tech companies work. They write something, they put it in a container, and then it's like somebody else is just pulling and putting layer over layer over layer. Okay, so now exercise 7, let's run a container. Girls that doesn't have access, you cannot do this because it's a GPU-enabled container. And we're going to use something that is called Horobot. So Horobot is a work frame, that allows to train or to deploy deep learning code in an easy, quote-unquote, way. So you can take advantage literally of your code, couple of lines of modification, and all the GPUs that you have at your disposal. So please start by copying the file, that file, Horobot GPU, from that direction into your folder, in the containers folder. Let me know if you should have access to that folder, as a matter of fact. If you don't have it, let me know so I can change the right now. Permission denied. Okay. I forgot to do that. Just kill this, kill that. Okay. Quickly. So, ch mode. Ibex, TMP, KVL, AI, and Horobot. GPU. Okay. Should probably do this like this. Just to make it. Try it now again. Try to copy. Still permission denied? Processing. Okay, nice. So did it finish? It's quite big, as a matter of fact. The file is not lightweight. Yeah. So if you go to containers, we have different files here. We have one single node Horobot and multi-node Horobot. Guess what we're going to do? We're going to S-batch them, as a matter of fact. So just before you do the S-batch, I want you to look at them in a nice way. So it might work for those of you that have GPU enabled. The first thing that you will notice is that I am asking 4 GPUs in one node. That's normal. I am actually asking B100 GPUs. The name is going to be Horobot demo. And right here, where it says echo PyTorch with Horobot and TensorFlow with Horobot, this is the actual syntax of a distributed run. Okay? We're going to do MPI run, number of processes 4. And then we're going to use singularity in this moment to run this file. Okay? Let's do it together. S-batch, single, no GPU. Let's see who gets the resources first, you or me. Oh, okay. Let's cancel this. Let's cancel this guy already. Nice. Mine is ready. Yes. So check it out. Tail minus F. It generated this thing. So as you can see right now in real time, it's doing iterations. What this thing is doing is using something called ResNet. It's a deep learning model that goes over different images, and now it's loading images in the GPUs and process them. Okay? I'm using 4 GPUs, so it's going super fast. As a matter of fact, I think it finished. No, it's 10 iterations. So it's loading around 350 different images in batches super quickly into the 4 GPUs. And it finished. Okay? Now, it should be doing the same. Tail F for this guy. Okay. Now I'm running the same thing, but with code of TensorFlow. The first one was PyTorch. This is TensorFlow. In theory, it's going to run the same thing. And it's going to start again, like doing the same stuff, loading images like in buckets into the GPU. And if I had only one GPU, this will take me at least 4 more, like 4 more times time. You can see it's going very, very fast. So can I go faster? Yes, I just have to ask for more GPUs. Now, don't get greedy, because that's actually a problem we have. Now we don't have all the GPUs that we could give you because we are many using them. So we don't have infinite number of GPUs. So take into account that if you ask for something, it might be still in the queue for a while this is running. Okay, so total images per second on 4 GPUs, 1,416 images per second. So if you have large databases, like 1 million different images, this will be part of your job, how to make it faster. One of the ways is using multi-GPUs. Okay, so that actually was done, right? Okay. Now, guess what? The other scales is not exactly demos. So in computers, well, in deep learning lingo, there is a thing called distributed training. So we can use PyTorch DDP, which is a way of distributing the load of the work in the GPUs using PyTorch. We are going to use that, and we can use also Horobot to do that, because Horobot also gives you like more flexible options. Why I'm telling you this, because in theory, if you are actually having a good code, what you want is just to add more GPUs or more CPUs, and the time goes down. And the more you add, the time has to go down and down and down. That's what is theoretically showing there in the graph. Like you start with 1, and then you are expecting half of the time invested if you put twice the resources, the computing sources that you're using. In theory, that's what it should happen. Not always is the case, right? Sometimes like showing here, it has this decay, but it's not quite stable. And sometimes it's not like that at all. So this is something for you guys that are going to delve into deep learning and data science, like heavy data science. If you have a code that can scale up, meaning that it linearly goes down the time you need to train your model or whatever, that's the best case scenario. You can do it with PyTorch CDP or Horobot or whatever you want. PyTorch actually have changed that to Torch Run. But this is the worst case scenario, when it plateaus. If you see the efficiency here, it seems that it's going well until it doesn't, and it just plateaus. So this might be an actual problem that you will face. Let's keep going over here. So this is the difference between Horobot and PyTorch. I don't know how updated it is, but take into account, Horobot scales very, very well. PyTorch, sometimes it doesn't, but it depends on you. How fast do you want to work? Okay, so exercise number 4, Horobot GPU. You already have it over there. So either add the constraint for B100 or silence the TensorFlow execution. It's just now SBatch, the other one, the multi-node, multi-GPU Horobot SBatch. Okay? Okay, matter of fact, the next one will be with PyTorch DDP. But that's in another folder. So if we do the same here, SBatch, and then multi-node, we do this. Let's see if it's running. it is running, meaning that I should have this. Hopefully it's outputting something soon. And it's the same output. It will go over the same example of 1, but what is different here is that now I'm asking for 2 different nodes, which means that I could go higher in the number of GPUs that I can ask. Okay, it's taking its time, but it's running. Now, at the end of this, you will see exactly the same number of image loaded per GPU per second, because we are actually asking for the same resource, but now it's just divided in 2 different nodes. What you might have checked out right now is that when it was running the warm-up, it took a longer time. This is because in the first example, we had the GPUs next to each other inside of the same node. In this one, we're actually just taking 2 from here and 2 from there, so they have to go over the NVLink, another connection, and probably the InfiniBand to communicate. But yeah, you have it here around the same type of the same number of images loaded. And the same should be for PyTorch. Yep. In iteration 2, 3. Okay. You got that? I'll give you a second. Yep. For me, it ended. And now I have around the same, a little bit less, as a matter of fact. But, 1,400 versus 1,387. Fine. But like I said, the difference here is that I can actually ask for a higher number of GPUs because I'm asking, there are 2 nodes here. If each node has 4 GPUs, I can have even a greater number of GPUs, making this probably more efficient for training or maybe just loading. Okay. Last but not least, yes. So, like I told you, you can do the same with PyTorch. Now, Torch, there is a, let's clear this. So there is a PyTorch DDP folder there. Once you're done with running Horobot, please go there. Now, in this one, there are 2 steps. First, we have to download the data. So do module load, machine learning. Okay. So that's step 1. Why I want you to do this? Because then I want you to do Python download data py. So this will create actually a folder called data with the data that we need for this exercise. Okay, so first go to Torch DDP folder, then load machine learning module, and then execute this file here, Python download data. Maybe I can get rid of this. Okay, raise your hand if you have the data. Remember, go to Torch DDP, machine learning module, download data. For those of you that already have the data, SBatch, single node, and after that, multi-node. Okay. Yours should be something like this. It looks like this, as a matter of fact. If you follow along, you cannot load the module. Because you are not in the login node then. Okay, let me give you one trick. Module ABRL. If you do this, module load ABRL, it will deploy these two. So do module load GPU stack. Okay. Okay. And then you do module AB machine. It should show you this. Okay. So this is a way to actually, if you're in the CPU login node, you can invoke or load all the GPU's applications that we have, modules, in this way. So now, because you have loaded the GPU stack of modules, then you can do module load machine learning, which works, yeah. Okay, my multi-node already finished. Oops. Gosh. Out. Okay. So in the out file, you should have something like this. A lot of warnings. And it's PyTorch complaining, like, no, I cannot do this. All right. Anyway, I want you to train. You load the machine learning? No, you do Python download. You already did Python download data? Okay, now SBatch both things there. Single node and then multi-node. Okay? Let them run, and they will come back with an out that looks like this. And it will tell you, okay, for 10 epochs, I am doing this in one single node or multi-nodes. And at the end, it will give you an accuracy. Oh, sorry. So the accuracy of the network in 10,000 images is 38%. Not so bad if you think that it took me 1 minute to run. I have this other one here. This one and what was the other one? $63, $19, $29. This one was the same. Okay. Out. Okay, so I must have the same here. Instead of that. We're going to do tail minus n50 over here. There you go. And 29. So I have 38 here. I did deploy all of that. Yes, if I put a number, maybe it will work. There you go. Ah, that's better. Okay, so in these two runs, I had different results, 2% difference of results. But at the end of the day, I was able to run in one single node with multiple GPUs or two nodes with different GPUs over 10 epochs. So each epoch, for those of you that know a little bit of deep learning, is how many passes do you do on your data set. So it was just 10 passes. Maybe I need 100. Fine. Maybe I need more data. If the data is not enough, you need more resources. If your training is not enough, maybe you just need more time. In this case, 38 versus 28. That's a big difference. Explained by I use one GPU that is very close. I use 4 GPUs that are very close to each other versus I have 2 nodes that have to communicate, go back and forth. All right? What I want you to take from home or from here to home is that you have now a GitHub repository full of different recipes that you can follow and modify to your liking for your job. And now you can actually deploy stuff in Ibex. If you forget how to do it, if you see at your left, we have a KVL channel with videos. And we have everything there. As you can see here, we have a teaser trailer for the next workshops. We have how to use Podman, how to use Singularity, how to deploy Jupyter Notebook, VS Code, RStudio. Explained again by me, sorry for my English. But there is more information for you. You can go back and forth. All the information is there. Spread it among your colleagues because I guess that you are here just by chance and your colleagues might not know about this. So pay it forward. Make everybody that you see that is newcomer or not able to do this aware of this kind of material that you have here. Okay? Well, that was intense. Thank you very much for coming. This is all the resources that you need. I guess I will not see your tickets on the queue unless it's something really, really, really important. So thank you for coming. This is the workshop. All right. Hey, where is the stream?